Hi, GCSE physicist. So this is a question here on transformers. So there's two equations that you need to know for transformers. They are two triple equations. So it means if you're doing triple science, remember you get 3 separate GCSEs, except different from combined science when you get 2 GCSEs. So the two equations are here. And normally I would say learn all your equations. I always say that. However, you always get given these equations, right? Doesn't matter what year you're taking a paper, you'll always get given these two equations. And I probably just then write them down. So if you see a question on transformers, go to your formula sheet and just write them down. So it's like one of the few times I would say don't bother learning the equation. So what is a transformer? So we know about transformers. You first learned them when you did electricity. Transformers are part of the national grid. Remember, the national grid is those transformers. It's the power station. It's the network of cables that carries the electricity to all the UK, all around the country, all of our homes. So one you learned about, and a key one you learned about, was called a step-up transformer. And a common question was, what's the purpose? And the purpose of a step-up transformer is to increase the potential difference. So again, the whole point is to increase the potential difference. Now we know from looking at this, it's a step-up transformer because step-up transformers will always have more turns of wire on the secondary arm. So we call this the primary, the first arm, and the secondary arm. So the secondary is just always on this side. So it's a step-up transformer, it increases the potential difference. Remember, the reason we said it does that is because we don't want to drop the current. Because we want the current in these cables to be as low as possible, right? Because we know a high current means loads of heating. Like think about when you charge your phone, the wires heat up. But we don't want these wires to heat up because that's going to be a loss of energy. So we want to have a low current to make sure we don't lose any energy. And the way we get that is by having a really high potential difference. So that's why I have step-up transformers. So what a step-up transformer is it's made of an iron. Okay, the reason it's made of iron, because we know iron is an induced magnet. So remember what that means is iron becomes magnetic in the presence of a magnetic field. So what I have here is an alternating potential difference. Remember, an alternating potential difference, if I can get my pen open, Christ. Need like a moment. An alternating potential difference just means the potential difference changes direction, right? It goes backward and forward. Now we know anytime we have current through a wire, what we get is a magnetic field. So because we have an alternating potential difference, we have a current that changes direction, we have a magnetic field that's constantly changing direction. Now because I've got a magnetic field here, there's my iron. The iron is an induced magnet, it becomes magnetic. So that iron carries that change in magnetic field over to the other secondary arm. So what I have now is a change in magnetic field and I have a conductor, a wire. And we know that anytime you've got a change in magnetic field and a conductor, what happens is you get an induced potential difference, right? That's our generator effect. So what now I get is an induced potential difference that's also alternating. Because I had a change in magnetic field cutting my conductor or passing through my conductor, I get an induced potential difference that is also changing. Now the math you know about this is that you can always calculate the voltage or the potential difference in P for the primary is divided by the voltage in the secondary. The voltage in the secondary arm is equal to how many turns are in the primary, the number of turns of wire, divided by the number of turns in the secondary, the number of turns of wire. So if I look at this equation, right now the voltage in my primary arm, I don't know what that voltage is in my primary arm, so I don't know what it is. Divided by the voltage in the secondary arm, it says here that it's 230 volts. So that's where we're going to, 230 volts. Equals the number of turns in my primary arm. The number of turns over here told me is 120. And let's say the number of turns in my secondary arm here is 2,400. So this one is upping the voltage from something to 230. So clearly this is not the one used in power stations, right? The one in power stations ups the voltage to a super, super high number to be carried around those cables, okay? But this one is only upping at 230. So this is not the one inside our power station. It's just a transformer that's going to increase the potential difference to 230. So I need to figure out what is that voltage in the primary. So what I do first, I'm going to simplify my maths. So what I would do is 120 divided by 2,400. So 120 divided by 2,400 gives me the number of 0.05. And I shouldn't have closed my pen. Gives me the number of 0.05. So again, my voltage in my primary divided by 230 is equal to 0.05. So if I want to get the voltage in the primary by itself, when you get rid of this, divide by 230. And when you get rid of something, you do the opposite of it. So the opposite of dividing by 230 is multiplying by 230. And we know that what we do to one side, we've got to do to the other. So what I'm doing now is 230 multiplied by 0.05. So 0.05 multiplied by 230 gives me a final answer then of 11.5. So what that says is that voltage in that primary arm was 11.5 volts. So that was the voltage here, 11.5 volts. So we can see we up the potential difference, we up the voltage from 11.5 all the way to 230. Okay, the other equation you need to know about is this one up here. It says the voltage in the primary arm, so again my primary arm, times the current in my primary arm is equal to the voltage in my secondary arm times the current in my secondary arm. Hopefully from looking at this picture, you can see, because of what we learned here, there's more turns of wire on the primary arm, okay? So what we're doing is there's less turns on the secondary arm. So this one must be a step-down transformer. So a step-down transformer drops the potential difference, right? We know from looking at it because it's got less turns of wire here. Now the question says a step-down transformer, we just said that, drops the potential difference from this number, so 11,500 volts on this side, to 230 on this side. And it says it's going to power a kettle at 2,000 watts. So I've got a kettle over here at 2,000 watts. So I'm going to calculate the current in that primary arm. I want to know what is that current in that primary arm. So what we do here is we assume that it is 100% efficient. Okay, we're going to assume that all of the power from the primary arm goes into the secondary arm. So we can use that equation. So all I do is fill in my numbers. So my voltage in my primary, I just said, was 11,500 times by my current in my primary. It's going to be my voltage in my secondary, which is said is 230, times by my current in my secondary. Right? But I don't have a current in my secondary. But they told me what the power was. And hopefully you guys all know that there's another equation in your formula sheet that says P equals IV. Power is current times potential difference. So when I have an I times a V here, that just is the power. So that just is the power. So because they give me the power there as 2,000, I can just fill in the number is 2,000. So now to find what the current in the primary coil is, I need to get rid of this multiplied by 11,500. To get rid of something, we do the opposite. The opposite of multiplying by 11,500 is divided by 11,500. And what we do to one side, we do the other. So what I need to do is 2,000 divided by 11,500, and I get a number of 0.17. 0.17. So that's my current in my primary arm. The current in my primary arm was 0.17, and current is measured in amps. So hopefully you find this video helpful. Please remember to take out the generator effect so you understand exactly how this transformer works. And there's loads more videos for you on YouTube, loads of information on my resources, and loads of past paper questions on TikTok. So be sure to check them all out. MES Does Physics.